Hi guys, the topic we are going to discuss in this video is the physical deposition methods which are used to deposit a thin film layer on any substrate material. The two techniques of the physical deposition methods which we are going to discuss are the thermal deposition and the sputtering technique. So let's get started. Depositing a thin film by PVD method can be done by either evaporation or the sputtering technique. It is most commonly and widely used method for film deposition. PVD involves physical ejection of materials as atoms or molecules and condensation of these atoms onto a substrate. These processes can be applied to various kinds of ceramics, polymers, alloys, and composites. Here are some steps which are involved in any PVD technique in order to deposit a thin film layer on any substrate material. Initially, the target is incident with high energy source which can be an electron or ion beam. The atomic vapors are carried from target surface to the surface of the substrate which is required to be coated. When the metal atoms of the target vaporize, they react with the gas which is intentionally introduced to react with the target material during the transport phase. Finally, a thin film layer is deposited on the substrate. Now, talking specifically about the first technique of the PVD method, that is the thermal evaporation technique. This evaporation takes place in a vacuum chamber which has a pressure in the range of 10 to the power minus 4 to 10 to the power minus 6 torr. A thermal evaporator uses an electric heater which melts the source material and raises the vapor pressure. Thermal energy is imparted to atoms in a liquid or solid source so that it can easily evaporate. These evaporated particles can travel directly to the deposited target without colliding with the background gas. And finally, a thin film layer is deposited on the substrate. However, the thermal evaporation technique can be further classified into four types based on the input energy. First one is the direct resistive heating, second is the indirect resistive heating, third is the inductive heating, and the fourth one is the laser evaporation. In the direct resistive heating method, the material which is to be deposited on the substrate is heated by directly supplying high electric current, but is limited to only few materials, example carbon, chromium, iron, molybdenum, nickel, palladium, aluminium, etc. In the indirect resistive heating method, the material which is to be deposited is put into a container which is generally called a boat or in the form of spiral wire or ribbon. Instead of directly heating the material, the boat or the ribbon is heated by supplying suitable electric current. In the inductive heating method, the evaporated material is heated by supplying suitable high or low frequency region, but the condition is that the evaporated materials has to be conductive in nature. In the laser evaporation technique, the continuous interaction of laser radiation with matter can lead to the thermal evaporation, and the material gets evaporated and thereby deposited on the substrate. Now, there comes a term called the sticking coefficient, which is the ratio of the reacted and the incident flux of the material. If the material has a high sticking coefficient, which is approximately close to 1, it means the material will deposit at the substrate where they will first strike. Instead, if the material has a low sticking coefficient, it means the material will bounce back and not deposit on the substrate, rather it will deposit on the side walls of the chamber. Here are some advantages and disadvantages of the technique. It is a very simple and cheap technique. It offers less surface damage of the substrate and excellent purity of the films is obtained. While on the other hand, it is limited to only low melting point metals, poor density and adhesion. It is not possible to evaporate dielectric materials, and the filament in the heater limits the amount of the material that can be deposited. This technique is used in the gold plating machines and the thermal insulation coating units. Besides thermal evaporation, vapor species may also be created by mechanically knocking out the atoms or molecules from the surface of a solid material by bombarding it with energetic and non-reactive ions. The ejection process is known as sputtering, and it occurs as a result of momentum transfer between the ions and the atoms of the target being bombarded. The sputtered species may be condensed on a substrate to form a thin film. During the process of sputtering, the target material and substrate is placed in a vacuum chamber. Then a voltage is applied between the target and the substrate, which acts as an anode. A plasma is thereby created by ionizing a sputtered gas like argon. Atoms or molecules of target materials are ejected into a gas form or plasma due to bombardment of this sputtering gas. Finally, the ejected target materials gets deposited onto the substrate and a thin film layer is obtained. Now, the question may arise, why we use only argon in the sputtering process? Well, the answer may be that argon is the most commonly employed process gas for sputter deposition process. It is because it has a high sputter yield for most metals and is chemically inert and non-toxic gas, which is relatively inexpensive as compared to the other noble gases such as krypton and xenon. And finally, if we compare both the techniques based on some parameters, the rate of deposition in evaporation technique is of the order of about 1000 atomic layers per second, while in the sputtering process it is of the order of only 1 atomic layer per second. And due to this slow processing in sputtering, it is always considered that the thin film deposited by sputtering process is always of the good quality when compared with the thin film of the evaporation technique. The choice of materials in evaporation is limited to only few materials, while almost any material can be deposited by sputtering technique. Similarly, all other parameters can be considered for both the techniques. Hope you have enjoyed this topic. Don't forget to like and share this video and do comment your suggestions in the comment box below. Thank you.